solve this pair of equations, 9 to the x equals 27 to the y, and 64 to the xy equals 512 to the x plus 1. As soon as we see two equations and two unknowns, we're thinking simultaneous equations. But how can we get these into a form that we can solve them? Well, looking at the first equation, 9 and 27 are both powers of 3. So let's write it as 3 to the 2x equals 3 to the 3y. And then by equating the powers, we get 2x is equal to 3y. Doing a very similar thing with the second equation, but we notice these are both powers of 2. We get 2 to the power of 6xy equals 2 to the power of 9x plus 1s. Equate the powers and we get 6xy is equal to 9x plus 1. Now we have two equations that we can solve to find the values of x and y. So how can we solve these two equations? Well, we're going to have to do a substitution here because these are not linear simultaneous equations. We know 3y is equal to 2x. So in the 6xy, I'm going to replace the 3y. Let me just write that out. I've got 3y times 2x. That would give me the 6xy is equal to 9x plus 9. But I know the 3y is equal to 2x. So this is really 2x times 2x equals 9x plus 9. But that is 4x squared, which means I've got a quadratic. So subtract the 9x, subtract the 9, put it equal to 0. I've got a quadratic in x, which I'm going to factorize. It's likely that with 9 here, these two are going to be 3 and 3. And 4x, 4 times 3 would give me 12. So if I make that negative 12 and then add on the 3, I would get to negative 9x. So x is equal to either minus 3/4 or x is equal to 3. And based on those values and this connection here, we can find y. When x is equal to negative 3/4, 2 lots of that would be negative 3/2. So y is going to be negative 1/2. And when x is equal to 3, we get 6, so y needs to be equal to 2. Two possible pairs of solutions here for this set of simultaneous equations.